So let's take a look at question 4 here. This one was one that you just had to use a formula guide for. Part A1 was all about coming up with the transformation matrices. So let's look at, we're going to look at the rotations pretty briefly, and we'll dive into the reflection in a bit more detail. So the first one is a rotation anti-clockwise. So we've got to use the formula guide. You're not expected to come up with these without it. I'm in section 3, HL section transformation matrices. It was a rotation anti-clockwise. So here we go. It's this one here. They gave us the angle. They said that that was pi by 6. So we can just substitute pi by 6 in as theta. Let's do this here. Okay, A per I. And it says to make it clear which each matrix is. So this is the rotation anti-clockwise. Okay, it was cos pi by 6. I think it was negative sign up here. Then we had positive sign down here. And cos again. All right, you can calculate this either with exact values or with decimals. If you're going to do the decimals, you're going to need the values later on. So it's worth using the full values on from your calculator when you do that. But this could be 0.866, negative 0.5, positive 0.5, and 0.866 again. Or you might use root 3 over 2 and halves. The rotation clockwise is very similar, so I'm not going to bother going through that. The formula in the formula guide is ever so slightly different. I think this the negative on the sign just switches position, and this time it's pi by 3. So same idea. Find the correct formula, substitute into it, and cos pi by 3, and we end up with 0.5, 0.866, negative 0.866, and 0.5. Okay, the one that is tricky that caught loads of people out was the reflection. Okay, it's a reflection of the line y equals x over root 3. I think it's easier if I do this in the formula guide actually. Y equals x over root 3. So you can see the formula guide talks about this reflection of the line y equals tan theta x. So we've got y, we've got x, which means that this over root 3 has got to be equal to tan theta. To make root 3 at the bottom of a fraction, we hold it in place with the 1 over. So that gives us an equation for what that kind of links theta to something. And you can see from the formula that we're about to use, we need to know what theta is. We don't want tan theta necessarily, so we're going to do theta is equal to the inverse tan of 1 over root 3. Which I did earlier. It's up here. You can once again write that as a exact value, or you can use the decimal. Keep the decimal fairly long because you're going to want to put it into the sine and the cosine functions. We're also going to want to double it because the formula says cos 2 theta. So that is 2 theta, 1.047 or pi by 3. So our matrix will be, let's put it down here. So it will be cos 1.043. Then it is sine again, and negative cos this time. Oops, there we go. So that's, once again, it's following the formula guide, but it is trickier because you've got to figure out what theta is. When you calculate this, let's do decimals as we've been doing decimals for all the others. We get this as negative 0.5. That is our matrix. Okay, so those are the three matrices. Reflection was the trickiest. Rotations should have been okay. All right, part A2, find the single matrix P that defines a transformation that represents the overall change in position. So it's basically combining the three. Just remember your order. We kind of work outwards. So if we've got some point, we're going to do, let's call these A, B, and C. We're going to do A to that point, and then we're going to do B to that, and then we're going to do C to it. So if we want to find the matrix that does all of that, we're going to want to find C times B times A. The obvious mistake is to do A times B times C. So just check your order, and that is A part 2. Part 3 is just squaring it, and what you should end up with is this, which is our identity matrix. Part 4, hence state what the value of P squared indicates for the possible movement of the drone. So what does it tell us? Well, the identity matrix means that we're back to an original position, and it happens at P squared. So once the drone has carried out the series of movements 2 times, it has returned to its original position. And obviously, if it does it another 2 times, it's going to be back in its original position again. So it's like it's kind of moving away to some other position with these 3 transformations and then moving back. Part B required you to know something. It required you to know that the area of the image is equal to the modulus of the determinant of your transformation matrix times the area of the object. What that means is area of your object, this is your original shape. So that is the triangle of the area of that original triangle of your 3 drones. Area of the image is the new shape. So what the area of the new triangle that they make is. New shape. You found the single matrix that represented all the transformations in A part II. So you have to do the modulus of the determinant. The determinant is in your formula guide. It is AD minus BC. That's the formula for the determinant. Let's see. Let's just find our answers. So I think the answer to A part 2, I'm just looking at the answer key quickly, is this 0.866, negative 0.5, negative 0.5, negative 0.866. So if we do AD minus BC to that, AD minus BC to it, whoops, and then we find the modulus of that, that will tell us how much bigger our image is. It turns out that that is 1, which is why it stays the same size. Okay, part C was tricky. Find a single transformation that is equivalent to the 3 transformations represented by matrix P. Matrix P is this one that does everything. This one here. So, this is the last part that I think we do need to talk about, part C. This is our... I'm just going to write it out a little bit neater because we need to kind of have a good look at it and have a good think about it. Right, these values 0.866 and 0.5 have come up a lot, and they seem to come up when we do cos or sine of pi by 6 or pi by 3. So that's something to bear in mind. They have come up a lot. You'll notice that one of them is positive, the top left element is positive, and all the others are negative. Let's have a little look in our formula guide. Because these are the... Oh, I've made a right mess of this, haven't I? Okay, these are our the matrices that tell us about our transformations. So we're saying that the first element and the last element have opposite signs. So looking at these, I'm looking down the bottom first of all, these rotations, it can't be either of these two because those are the same value. So it can't be either of those reflections. It can't be an enlargement because they're both K. These would need ones. It can't be those. It's got to be this one here. And if we look, we've got a positive cos and a negative cos as our first and final element. So that's kind of fitting with it. The other two elements are equal. Let's check. Are our other two elements equal to one another? They are. Okay, so this tells me it's a, what was it? A reflection. Okay, we know that cos 2 theta is equal to 0.866, and we know that sine 2 theta is equal to negative 0.5. Our reflection is going to have the form y, it's going to be in a mirror line, isn't it? And it's y equals tan theta x. So what we're going to have to do then is figure out what theta is. So if sine 2 theta equals negative 0.5, let's figure out what 2 theta equals. Let's do the inverse sine of negative 0.5. Let's try it. Inverse sine negative 0.5. Okay, I've got this. I've had this number before. It was negative. It's now negative pi over 6. Negative 0.5235. 52325, I think it said. Oh no, extra 2 in there. Let's get rid of that. There we go. So that's 2 theta. Obviously, we want 1 theta. We've got to halve it. Divide by 2. Okay, negative 0.2617. 2617. Okay, that's theta. But my line is y equals tan theta. So let's find tan theta. Tan theta equals this. And it has not changed. So tan theta also equals this value. Okay, so the reflection line is y equals negative 0.268x. Okay, that is a tough question. I think, yeah, part A, looking back at it now that we see the formula guide, we should probably do a little bit better with it. Lots of you did, like, you got some pretty interesting values, but you kept going with the question, which is really good to see. Part C would have been impossible, unless you got very lucky values, it would have been really difficult to do anything with, because you're trying to kind of figure out what's happened. So part C didn't really stay open to you, unfortunately.